We want to show that mx equals my, or that mx divided by my equals 1. From our triangle similarities, mx divided by my equals xr divided by yt, and mx divided by my equals sx divided by yu. Multiplying these together gives us mx divided by my squared equals xr times sx divided by yt times uy. Switching the denominators gives us the right side of the ratios we obtained from the other pairs of triangle similarities. If we substitute xr divided by uy for ax divided by cy, and sx divided by yt for dx divided by by, we get mx squared divided by my squared equals ax times dx divided by cy times by. Before we continue our proof, we need to prove the intersecting chords theorem, which states that if two chords, AC and DB, intersect at a point P inside a circle, then AP times CP equals BP times DP. To prove this, we use the fact that when two inscribed angles subtend the same arc, they are equal, to show that angle ABD equals angle ACD, and angle BAC equals angle BDC. Then we have triangle ABP is similar to triangle DCP because they have two sets of congruent angles, so the ratios of their sides AP divided by DP equals BP divided by PC. Multiplying both sides of this equation by DP and by CP gives us AP. If we want to use the intersecting chords theorem to help advance our proof, we must first determine which chords would be helpful. In our equation, we have mx squared divided by my squared equals dx times ax divided by by times cy. We want to use the chord AD with the point of intersection being x and the second chord being PQ, because then by the intersecting chords theorem, ax times dx equals px times qx. Then we want to use the chord CB with the point of intersection at y, and then the other chord is PQ. So C. Then we substitute out the products we got from the intersecting chords theorem to get mx squared divided by my squared equals px times qx divided by py times qy. If we substitute px for mp plus mx, qx for mp minus mx, py for mp minus my, and qy for mp plus my, we get an equation in terms of mx, my, and mp only, which is mx squared divided by my squared equals the quantity mp minus mx times the quantity mp plus mx divided by the quantity mp plus my times the quantity mp minus my. Distributing the right side using difference of squares yields mp squared minus mx squared divided by mp squared minus my squared. Cross-multiplying yields mx squared times mp squared minus mx squared times my squared equals my squared times mp squared minus mx squared times my squared. Subtracting out the mx times my terms and then factoring out mp squared yields mx squared equals my squared. So then mx equals my, which completes our proof.